Hello, this is problem 3.2. So before we start solving the problem, I want you to notice numbers in this problem. We have 1/10, we have 10, we have 1/1000, and we have 10,000. So all these numbers can be written as powers of 10. So as a little review on the side, I'm going to remind you of how to convert to decimals, or how to use powers of 10. So if we have, for example, 10 to the power of 0, that's 1. 10 to the power of 1 is 10. 10 to the power of 2 equals 100. 10 to the third equals 1000. 10 to the fourth equals 10,000. Now I would like you to notice something here. Here you have power of 1, and then you have 1 0. Here you have power of 2, 2 zeros. Power of 3, 3 zeros. Power of 4, 4 zeros, and so on. Now let's look what happens if we have negative exponents. Well, similar but backwards. If we have 10 to the negative first, it's just like 10 written backwards, and then we write decimal point. 10 to negative second, okay, 1, 2 zeros, put a decimal point here. 10 to the negative third, 1, 3 zeros, put a decimal point here. 10 to the negative fourth, 1, 4 zeros, and decimal points, and so on. So what we need to notice here, if the exponent of 10 is negative, it gives us numbers of zeros, but it goes backwards to the left. 1 0, 2 zeros, 3 zeros, 4 zeros. We're going to use these facts over here to simplify our problem. All right, so let's look here at 1/10. So 1/10 could be written as 0.1, which is 10 to the negative first. So I'm going to do that first. So this is 10 to the negative 1, but the whole thing is to the negative third, so I'm going to copy that. Next we have 10 to the fifth, which I'm just going to copy. In the bottom we have 1/1000, so that would be 10 to the negative third. We have 3 zeros, so that's 1000th. And then, so this here is this, and 1/10 is this. So now we have 1/1000 to the third power, so I'm going to put third power here. And finally we have 10,000, which is 1, 2, 3, 4 zeros. So that's going to be 10 to the fourth. So this part right here is 10 to the fourth, but then it's raised to the negative 5. If you look at our problem now, you see everything turns into simple exponents. So we're going to simplify a little bit here. So I have 10 to the negative 1 to the negative third. By rules of exponents, we multiply negative 1 and negative 3 and get positive 3. So that's just going to be 10 to the positive third times 10 to the fifth. In the bottom we have negative 3 power and then to the third. So power to a power means we multiply those two powers. So we end up getting 10 to the negative 9. And finally we have 10 to the fourth and then to the negative fifth. We're going to multiply these two powers, end up with 10 to the negative 20. Now our problem simplifies even more. Now remember, when you have same base, so we have 10 and we have 10, and when you have multiplication, then what you do with exponent is you add them. So 10 to the third times 10 to the fifth is same like 10 to the power of 3 plus 5. And same thing in the bottom, we have same base, 10, 10, we have multiplication, and since multiplication is just repeated adding, it's same like 10 to the power of negative 9 plus negative 20. Simplify. Here we have 10. 3 plus 5 equals 8. In the bottom we have 10. Negative 9 plus negative 20 is negative 29. Now we have division. So remember the rule. We have same base, different exponents. Division means subtraction, repeated subtraction. So our result will be 10 to the power of the top number, 8, minus the bottom exponent, minus negative 29. And if we simplify that, we end up with 10 to the power of 8 plus 29. And our final result is 10 to the power of 37.